Yesterday we learned law of signs. Please use law of signs to find the other sides of that triangle. Draw the picture, write the setup. Homework tonight is on Delta Math. If you are not signed up on Delta Math, please do that. The link code is in the top module of Canvas. Now you gotta use the prep link. Sorry, do your own food. Oops. She's on one side. Elia, you're done? What do we set up? You have something. You have one. You have something. What's this? Or is this from notes from yesterday?
No, this is.
This is today?
Bro, one of these triangles takes up a whole page.
Sorry, hon. Get it? No? Okay. What'd you do first? Take this down. Okay. So guys, first thing Joseph's saying is sine 38 over 12. No matter what you chose, you needed that particular pair because it's the only two you know both things. Nick, then what did you?
I kind of skipped a bunch of steps, but
Okay.
you would make it equal to sine 82 over lowercase e.
Okay, so then the only angle that's left in there that we were told. All right, Will, do you remember the shortcut?
Yeah,
So-
you flip them. So then you do 12 times sine 82 divided by sine 38, and then when you do that, I got 19.
19.3.
Yeah. Did you get that? Yeah. And then, but I did it a little differently. So not
Okay.
like I did the same thing, but I just first found all the angles. So I did 38 plus 82, which is 120. Then you know that your other angle is 60, and then from there you can find the other angle, which is across from it.
Okay, perfect, great. I don't care which order you do them in. So doing the math, let's check, make sure I'm in degrees. I am. So 12 times sine 82, you need to remember to close the parentheses, divide by sine 38, close the parentheses, equals, so this side is 19.3-ish. It didn't tell me how to round, so I'm gonna pick whatever I want. Ben, how do I get, so Will told us how to find the other side. Sorry, should I ask someone else because you're mid-snack? Renee, how do I find that side? Well, I need to set up the whole thing. So I'm gonna use the one that Joseph found for us first. Sine of 38 over the side across equals sine of this guy over the side across. What is the angle that Will found for us? 60 degrees, because all three angles in a triangle add up to 180. He said 38 and 82 add up to 120. 180 minus 120 is 60. So sine of 60 over the thing we want to know. And then you guys said flip the whole thing because it's a little bit easier. And then multiply by sine of 60 on both sides. And 12 times sine 60, remember to close the parentheses, divided by sine 38, 16.88
Yeah.
or 16.9. Again, I didn't tell you how to round, so if that happens on a quiz or a test, and you ask me, I'll say pick something reasonable because I didn't specify. Okay. Today, we need to do this thing called the ambiguous case and determine when there's more than one triangle or no triangle. There will be a quiz on stuff, hopefully simple, crank through it, and hopefully you'll all have your own calculator that you're used to using, not the emulator on your phone. Hopefully you'll have one of those by Thursday.
We have a quiz on Pi Day.
I know, it was kind of on purpose. I mean, it wasn't, but then it was like, oh, it's Pi Day.
That's so fun.
Hi, who's the winner?
You. Excuse me.
Johan, you're in trouble again, bro.
I lost my student ID.
Student ID again.
Let me see who's doing that.
Uh-oh.
Oh, bad catch,
I just get this ID this morning.
Oh my goodness, Johan.
Oh my.
All right, so we just did this. Okay, so look at those questions. Just can you think about it, or and just kind of get a sense of it, or no? Like, can I make a triangle out of those three sides, like 3, 3, and 3?
Yeah.
You can. How do you know?
It's kind of like equilateral triangle.
Equilateral triangles happen. So yep, that one works.
So they're all
Equilaterals are okay.
They're all gonna be the same angle,
That's a
right?
right triangle.
3, 4, 5 is like, if you don't know that one's a triangle and it's a right triangle by now, Jesus. We just got out of trig, you should know. Okay, what about 3, 7, 10?
I don't see why you couldn't have it. Truthfully.
Okay, what about 3, 7, and 100?
Actually, oh,
Yeah, that's one.
Not bad, that's too long.
Is it
I
though?
think so. I don't think it-
Okay, so this one, let's think about this one. Here's length 3, and here's length 7. And they're gonna take their two little tiny T-Rex arms and try and hold hands. We're going on with 100.
Yeah, I think that's way on the guess.
Can the two little guys, 3 and 7, are they gonna be able to like take their little teeny tiny T-Rex arms?
No.
No. Okay. Okay. Well, what about this one? 3, 7, and 10.
yeah.
Yeah, it's probably.
Yeah.
That makes
The seagull, yeah.
Okay. Y'all,
It's just a little bigger than 7.
that's a flat like a pancake. Is that a triangle?
It's not.
No. Okay. It's gonna be flat like a pancake. Yeah. Okay. So here's my fancy like stuff. I don't like. Okay. So we got the silver line. Yeah.
How 3, 7, and 100?
We're okay.
Impossible.
Okay. William, look. We're gonna say the silver one. That's the 7. We're
Okay.
gonna say the little blue index card. That's the 3. Right.
Oh, actually possible.
So 7 and 3, if I stretch them all the way out, how long is the red line that's squished?
10.
10. Does this make a triangle?
No.
Oh,
No.
no, it don't.
So, then, no, it don't. Alright? Yeah. It don't. So,
But the
but what
three
if the
goes
red
up like
line
that.
was just a little tiny bit less than
Triangle.
triangle? Okay. So, my third side
Impossible.
had to be less than
The 2 first side.
the first two added together. So, we said 7 and 3, if it was exactly the two of them added together, flat like pancake. Yeah? Yeah. Pancake. Alright, what about the other way? Silver line, we're gonna, here's the 7. And there's the 3. We're gonna fold the index card in. When it's flat like pancake this way, how long is the red stick?
4.
It says 4. Because 7, and we're folding the little guy in. the silver line is 7, this is 3, and Nick says this is 4. Yeah? Does that make a triangle? No. What if the red thing is just a little bit bigger? So whatever your third side is has to be bigger than the difference, smaller than the sum. Can we write that rule down? William, yeah? Bigger than the third side needs to be bigger than the difference and smaller than the sum. Okay, Van, you finished breakfast. Pick a number.
7.
7. Pick a number.
5.
Monica, pick a number. What? 3.
Possible.
Alvin, do those make a triangle? 7, 3, and 5.
Possible.
Possible.
Yeah? How do you know? Let's test our rule. How do you know? Okay, hold on. First, of these 3 numbers, which one do you want to pick as your third one?
Oh.
Okay, the 3. So the rule was that third side had to be bigger than the difference. What is the difference between 7 and 5? 2. Is 3 bigger than 2?
Yeah.
Okay, so we're good so far. And then smaller than the sum. What is the sum of 7? Okay. So he's right. Cool. Awesome. Peter, pick a random number.
Let me pick
10.
one.
Okay.
1 billion.
Wow.
Tricky.
I'm going to cut that off.
Okay.
And
Wow. Possible.
Yes, it's possible.
possible? Okay,
So
well, let's pick. I'm gonna pick this one as my third side.
'Cause
What's the sum of these guys? Is 10 less than that?
Yes.
Solidly, yes. What's the difference between these
Oh, no,
guys?
it's possible. It's not possible.
201. So it's not a triangle, right? Simple enough? Okay, cool. Moving on. Because today, we need to do this thing called ambiguous case. When we do sine inverse of a half, we get something from first quadrant and something from second quadrant. Can a triangle have a 30-degree angle? Well, 30, 60, 90, all over the place. Sorry, get off the phone. Can it have a 150-degree angle?
Yeah.
Yeah. So, when we do law of sines and do sine inverse, we might have gotten 2 answers. There's an issue. I know, it's exciting. Okay,
But
I know, complain, draw the triangle.
See. Is it a 3 or an 8?
Sorry, that is an 8.
Do you want us to finish it?
Sure. Find all the parts of the triangle.
No.
Thanks, Nick.
We're gonna do that anyway. We're gonna do it twice, Fernando, twice.
Whoa, but we don't have the missing angles, so that's what we're gonna learn.
We did. But
Oh,
we
no,
only,
we do. No, we can't.
74 is Z.
Oh, understandable, because you can do sine of z over 12.
Or 75.
so what angle do you guys get?
74.6.
How do you guys do it so
Or
fast?
74.62. And then inverse sine.
So first of all, don't tell me that the angle is 0.9. Because it's not the angle, it was the sine of the angle. And Nick says do inverse of that. And we got 74.6. Are you guys okay if I round it to 75? So it's a nice
Yes,
number?
please.
Okay.
Please.
So Z, we're gonna say is 75 degrees.
So now we can do 75 plus 40 minus.
Actually,
Yeah.
Serene, are you okay with that?
But how does the 0.64?
0.964. Serene, its sine of the angle is 0.964. How do we find the angle? We do sine inverse. Say, put in the ratio. Yeah? Okay. Mara, how do I get that third angle Y?
I need some help. The same thing.
It's okay. 180 minus 40 minus 75. William, what do you need help with?
So I'm stuck. Can I show you? I'm stuck because I know how to do the other ones where it's like an angle and then this thing. How do I isolate the Z?
Okay, well, multiply both sides by 12, and that's where I got that 0.964.
Okay, wait. And then
Hold on.
That's cool.
Monica, what do I set up to find this side Y? Y over sine of 65 equals, what's the rest of it? 8 over sine of 40. So she's doing this upside down from what we did. Is that okay? She's saving the flipping step. So she did a good thing right off the start. Okay? Tycho, what do I need to do to just find Y?
Multiply by sides.
William, you okay with
Yeah,
this?
I got it.
Okay.
You just do sine inverse, right?
Yeah.
Okay, yeah.
All right, so sine 65 times 8 divided by sine 40. And I got 11.3, okay?
Yeah.
All right, however, I need to show you this thing that is the ambiguous case.
Oh my goodness.
So I gave you an angle and two sides.
why is the side swing?
Because it's T-Rex arms can't reach the other side. So, oh goodness, if I could just type. Well then, I will just type. I could have no triangles be able to be made, or maybe exactly one triangle, or this is the thing that's the ambiguous case. Maybe I have this skinny little triangle, or maybe I have the big, huge one over there. So looking at this example, back here when Nick did sine inverse, and we got Z was 75 degrees. What is that angle in, Joey, what is that angle in quadrant 2? The 75 degree angle, reference angle in quadrant 2.
I see.
105. Joseph typed it in. And can I have a triangle with a 105 degree angle in it?
Yes.
Maybe. So let's check our triangle. If we redrew it, it's not drawn to scale. But if this is 105 and that's 40 and this is 12 and that's 8, are there enough degrees to go in that top angle? Oh, bummer. So this is an ambiguous case. Roscoe, how big is that angle?
35.
35 degrees. So there are, on your Delta Math homework, there are things called the ambiguous case. And they're going to ask you, how many triangles could you have made? 0, 1, or 2? Here, when we did sine inverse and got the angle, 75 degrees, check. Just the extra one. In quadrant 2, 75 degrees is 105. Could this triangle have handled it? Yes. guys do law of signs to find that last side. So there's two different ones that could have happened. We found one, now find the length of that other side, now he's assuming you're not following me, that's what's.
You gotta also do that ambiguous triangle.
Cause she made the other.
Okay, did you, so you saw the
Yeah.
thing, and I was like, this side, and this angle, we got here, or out there.
Where's 105 come
Because that's when you go to quadrant 2.
I'm so lost right now.
Okay,
Oh, you're taking
when we
sine
did sine inverse, sine is positive in two quadrants. It was 75 degrees in quadrant 1, and it's 105 degrees in quadrant 2.
Oh, you just start subtracting the line.
Yeah.
Like, I feel like the easy way to avoid this would just be specify where you want your line.
Unfortunately-
Quadrant, or,
Right, but sometimes
What are you
it's just,
because I see what they're saying, like, it's, if you have like the
Okay,
quadrant 1,
Good
quadrant 2,
weekend,
you don't
okay?
have anything in quadrant 3. You wouldn't have anything in quadrant 3 or 4, right? Because the angles just wouldn't go that
Yeah.
high. So you're really only working on like a plane
yeah,
like
but
that.
well, sometimes in the calculations of things, both answers are accurate, and you need to do something else to be like, well, we wanted these dimensions, do you want the big angle, or do you want the little angle to fit in whatever context your problem is in? So,
So you just redid the triangle, but then with the other side of the triangle.
yes. So this is now just saying, well, sine of 105 over 12 equals sine of 35, whoa. Sine of 35 over y. I didn't do it the smart way like Hanukkah. So, sine 35 times 12 divided by sine of 105. In this other orientation, this side is length 7.1. Right? Yes?
Question. So you use sine of like 105. What if I use sine of like 40? But I can still get the same answer.
Yeah, as long as you used this angle of 35. Sine of 40 over 8 equals sine of 35 over y.
That's
Yes,
all the
yes,
triangle.
yes.
I'm just so confused why you made a whole second triangle.
Okay,
Because it wouldn't work without it.
okay, didn't have any answers on that.
I got one.
So,
Yeah.
so maybe when I did sine inverse and I get this angle over here, maybe it really was a small angle of 70 degrees. So I told you this side is length 9, that guy's 16, and this angle that's not squished between them is 30. So finding this one, maybe it was 70 degrees, and that worked. But maybe it was this big fat triangle, like this with this wide angle. Maybe it was this 110 degrees and this length of 9 and that length of 16. They can both work with those dimensions. It's just a thing, and the word ambiguous means, I don't know, is it this one or is it this one? The answer is yes. Peter?
How do you find the other triangle?
How do you find the other triangle is when you do sine inverse. Nick did sine inverse for us and got 70, what was it again, 72? 75? 75? Okay, maybe it was bigger angle. Maybe it was 105. When I looked at the triangle, which is now at the top of the page, when I look at this triangle, it works with 75, cool. But it also works with 105, and you need to check both. It's the hard part of this unit. It's the trick.
Yeah, but where do you get 105?
Because it's 75 in the second
Well,
quadrant.
why did you bring quadrants into it?
180 minus 75 to get the bigger.
Okay, hold on. Let's try this again.
But for your 105 triangle, shouldn't one of your sides then be negative too?
No.
And then, but it's in the second.
Oh, like the x value that gets you there, yeah. But the length is actually put down a ruler and measure it will not be negative. Yes,
You can only check it in the first and second quadrant.
correct.
But why did you bring the quadrants into it? That would equal sine inverse
So sine inverse of a half. Where's sine a half?
of
In 0 to
5 over
360.
6.
5 or 6, which I did just change it to degrees because we're now doing that. Where else? 5 pi over 6, which is how many degrees?
That is the same.
Okay, well, William, can I have a triangle with a 150-degree angle in it?
No. Well, yeah, but
Yeah.
it would look kind of funny.
So it looked kind of funny, but they happen.
Yeah.
Long skinny triangles are triangles too, hater. Gosh. So find the angles. Do them the normal way. Yeah.
How do you know which angle to check from? How do I know? Like on the last one, you checked from 75, and that's how you got 105. But why couldn't I check from the other one up top?
Okay. Well,
So you give us one angle and you say check for I, but why can't I check
Okay.
for each?
go ahead. How are you going to do that? When I set up law of sines for this, I need to use 16 over sine of 30. Those are the only ones that I know the pair. Do I know angle H?
No, but you.
Do I know
find-
the side across? They're both unknown. I can't use that one in my law of sines. This
But
is,
you can find it by the end. Like by the time that you'd be checking, you.
Okay.
would have-
all right. So right now we have to use this pair. So 20 over sine of I. Find angle I. Monica, stop staring at me with blank look. Please count me.
Would it be more like effective to do
I got
it? Like,
I got around
I just feel like it's easier
39
to visualize when it's like
No.
high.
But they're not gonna be nice numbers. It's gonna be like 0.3.
It would be like pi over 7.
I got
No.
I to be 39.
Okay, so, William says he got pi to be, what?
39, 38.6, but I rounded.
All right, so let's try it. Sine of 30 is a half, 20 times a half is 10, divided by 16, sine inverse of that. It's about 38.7.
So 39.
So, all right, we'll call it 39.
So now when you just.
So hold on. Right now, Peter, what is the other side of that angle? If this is 39, what's the bigger angle? 129, would you say? So let's
141.
180 minus 39,
111.
111,
No,
141,
141.
141. Okay,
Wait, no, but don't you to add 8 for them, and then you get 69?
okay, hold on. So let's check. Like,
Oh, I was trying to
Does-
find the angulation.
if this was 39, what if I put the bigger angle in there? We have 149 plus 30. Are there enough degrees to fit in angle H?
I mean 141.
Sorry, 141 plus 30. Are there enough angles in for H to have some something or other?
Yeah.
141, 171. It's
29.
tiny, but it's 9 degrees. So it's possible, which means you need to find both triangles. So this one, you're right, 39 worked, and I would do 30 plus 39, subtract that from 180 and get a big fat angle H. Or maybe the big fat angle was angle I and H was skinny.
How do you determine which angle you would use, like, as the one in quadrant 1? Like, I would just use.
You've got to do both. Straight
You
up,
have
period.
to do 39 and 30 in quadrant 1?
Okay, the
Well,
30's
which
already
angle?
given. 30's not in question. I'm telling you.
No, I know, I'm saying which angle you picked. one to put in quadrant one and then
So you have to
find
do
which
the,
would
you have
be
to
the
do,
second
you have to do
easiest.
111 and what, 39?
Yes,
In
okay,
quadrant,
so we need to do both. So I'm gonna find,
so there could be three triangles.
no, there's only two
As long
choices.
as you have parentheses.
So either angle I was the little guy, 39 degrees, or angle I was the big fat one. I don't know which one. I am asking you guys to find both so we can choose. Sorry, Noah, no kibbles.
So, when you like switch, like the inner angle, does the side still stay the same length? Or like, do you like look for like side
Okay,
20?
the only things that have to be true is the side across from the 30 degrees is 16, and the side across from this eye that we don't know how big it is, that eye is 20. And so, like this side was 9, this side was also 9, and it's across from the 30. This guy, this length here was 16, but maybe this angle at B2, maybe it's a big fat guy. Or maybe it's the angle at B1 and it's a skinny, littler angle. Both of them work.
You guys can-
Because look, woo, wee.
It could be either triangle.
It could be either triangle, yes, holy crap. Hence the word ambiguous. So then you gotta find all the pieces of both things, because maybe he wants the big fat one and he wants the skinny one. They both work.
Why? You gotta find that for everything.
Yeah. So every single, it's only 3 pieces, so
So
angle H when it's the little angle for I. Easy enough to do.
111.
111.
39 plus 30, subtract that from 180, 111.
Or none.
Right?
Right, and then the other one's
I
9.
don't know what direction it goes in. Like, I don't know
The
what
other
order.
one, that's 9 degrees. So all you have left to do is find the little H side. Is it the skinny guy or the big guy? Find them both. Like write stuff down, type things in.
How do we pick which is the right after we?
You don't
Oh, both are
know.
the answer?
They could both be answers.
Okay.
Wait, H is 9 because you have 111 then plus 39.
No. This is triangle 1.
Yeah.
This is triangle 2.
No.
So 141 plus the 30, I get 171. There's 9 itty bitty degrees left for the
So-
last.
20.
So the 30 you don't. All right, the 30's given. So then
Okay, so for the 111 triangle, little
So-
H is 29 point.
They're both going to have an obtuse angle. There's an obtuse angle here, or there's an obtuse angle there.
Wait, what?
I kind of get it. It's like if it's flat, like you could have a big angle there and then the smaller angle where I is. Or
Okay,
you could
so
have a
then-
large angle where I is.
So the where she drew the first little thing, that's 111, and I'm sorry, that's 141. Or that's 111.
Either angle I was this 39 degrees, and then in quadrant 2, 39 degrees, 180 minus 39 is 141. So either angle I is that littler 39 degree angle, or
Okay.
it's that guy.
Gotcha.
And when it's this one, this big fat angle, H would be that 111. When it's the little skinny mini guy,
9.
H would be 9 degrees.
Okay, so
And you
across,
still needed to find the side eye.
so across from the 111 one is 29.87.
Thirty, what's your question?
Like for both, like what is the equation to get
I don't know.
the H?
What's the equation to get H?
You have to do it twice.
All 3 angles of a triangle add up to 180. So 180 equals 30 degrees plus angle H plus angle I. And we got 2 different choices for angle I because That's the way trade works. Acute angle, that gives me sine angles, but sine is positive and
Wait, can
quadrant
we do the
too.
math now?
Can we do
Of
another
the-
question and you do it like linearly instead of just like putting it like in different spots?
But, okay, all right.
Because I feel like when you like put it in different spots, I don't know like if there's an order to it.
Wait, we never solved
Hold on, we never solved it, you're right. Okay, to find the last side. To find,
Well, you're finding two sides.
well, the last side for two triangles.
Yeah.
Okay. So, should we do, Joseph, you pick. Should we do the big fat H angle or the skinny H angle? First, you gotta do both.
Start with the big one.
The big one? Okay. So we're gonna do sine of the 111 over H equals the thing that's set, sine 30 over 16.
29.87.
So we could get 16 sine 111 divided by a half. 29.87?
Yeah.
What if it was the big fat one, or sorry,
The second one?
the skinny guy? So the only difference is it's now sine of 9 degrees.
What is that? Seems like where that 9, like if you see a little flat or whatever,
Five.
you cut it down the middle.
Okay.
So it's
That's the part I was
5.
kinda confused.
Point.
I think
Okay.
this is-
All right, let's try one of the problems
So, wait,
from here. Yeah.
we didn't finish.
Yeah, I'd like to, as Fernando said, can we do it like organized?
Yeah.
It's basically what he's asking for.
Wait, was that not?
So, let's try ABC. That's 32, this is 17, and that's 11. There's only one thing we can do to find anything at the moment. Mia, what's the one piece of information I can find right now? Can I find angle C, angle B, or side C?
Angle B.
Angle B is the only thing we can find. All right, so Fernando, what do I set up to find angle B?
Sine of 32 over 17 equals sine of 32 over 11.
Yes, sir.
Okay, so do that. Find on your calculator. Sine of B, 11 sine 32.
20.
So is my angle point 34 degrees? No, Sarah, what do I need to do to get the angle? I'll do what I have to do to get the angle. Sine inverse. Sine inverse, undo sine. So I get 20 degrees. So right here, check. What is that 20-degree angle as a reference angle in quadrant 2? If this is 20 degrees, how much is the big angle that got me there? 160. Okay, right here, can I have a triangle that's 160 degrees and a 32 degrees?
No.
No, so right there, that's dead, that's done.
So you only have to find.
I only have to find the one.
That's
So it's
nice.
always just
Okay.
the reference.
So- So, but if this came out to 100, then it would have worked.
But it didn't.
So this one it didn't. So Fernando, you okay with this so far?
Okay, 160, if you have, say it again?
Okay. Sine inverse on a calculator.
Yeah.
What two quadrants does sine inverse come out of? Being positive.
1 and 2.
Quadrant 1 and 2.
Yeah.
So a 20-degree angle, or that 20-degree angle in reference angle over here is 160, right? So those two things could have been in a triangle. Did it work here? No. So I only get one triangle right now.
Is that because of the other
That's because,
other formula we have?
well, it's because the three angles have to be 180,
Oh.
and that made it 190 something with just two of them, so
Okay.
it's done. Hold on, Tycho.
So the 160 was because of the wall.
Then all the angles in a triangle have to be 180.
So basically, you just check every angle.
So when you do sine inverse, when I only give you one is the only time it's a problem. One angle, you maybe get two things, you maybe get one thing, you gotta check. So check both and be like, oh,
This one.
you're too fat, you out. Not to be, mean about it, but too fat. Yeah,
Can I finish it?
okay, sure.
Do you want me
So, yeah, okay. So this guy's gone and he's an actual 20-degree angle. Go for it.
to, oh, you want me
Okay,
to-
all right. So how do I get the third angle?
Well, you just do 180 minus 2 minus 20, which is just 128. Oh, it's
128. Okay, so
Alright, so now you do sine of 128 times 17 divided by sine of 32.
sine of 128 over the side I want to know equals
My bad, I skipped this stuff.
sine of 32 over 17. Turn everybody upside down and multiply. 17 times sine 128.
25 32.
I don't know why it is over. That did not ring. 17 times sine 128 plus the parentheses divided by sine 32. 25.27.
28.
28. Okay. So, please do the delta math. How many of you are not on delta math yet? So that I can see when you log in. I can see when you are sleeping. I can see when you're awake. I can see every keystroke you click. So don't tell me like, oh my God, it's been 3 hours doing the delta math. No, you didn't. It was 3.5 minutes. Like, hell. Doesn't ring. It doesn't ring.
I'll get a ring, buddy.
I'm saying concentrate. It's not actually that complicated. It's just hidden.